Welcome to this Esri Developer Summit technical session, Building Apps with ArcGIS Runtime SDK for .NET, Part 2. My name is Mike Branscombe, and I'm the Product Engineering Lead for the SDK. I'll take you through the first part of this session, and later we'll be joined by my colleague Morten Nielsen, Software Engineering Lead for the SDK, and we'll also be supported in this session by some of our colleagues on the .NET team. This session, titled ArcGIS Runtime SDK for .NET Building Apps, is split into two parts this year. In the earlier Part 1, we provided an overview of the developer resources available to you and introduced building desktop and mobile apps. In this session, Part 2, we'll take a deeper dive into several important new features and capabilities we introduced over the last year since the previous Dev Summit. In this deep dive session, we'll cover important changes to the structure or the hierarchy of our NuGet packages. We'll look at moving to the latest release of .NET, .NET 5. Credential Persistence is a new feature we introduced first in April last year, and then we followed up in the summer release with default implementations that you can use out of the box on Android, iOS, and UWP. The latest release of ArcGIS Runtime in January includes new support for high-accuracy GPS receivers and using web styles. And it also now fully supports nullability or nullable reference types. And then finally, we'll take a brief look at the road ahead. So what was new in releases over the last year? 108, 109, and 110. Well, the blog posts that we publish at each release highlight specific details that are new for .NET developers when working with ArcGIS Runtime. We introduced nullable reference types, support for .NET 5. We re-architected or changed the hierarchy of the NuGet packages into runtimes and application platforms. We added that credential persistence with default storage for Android, iOS, and UWP. We improved dark mode support. We improved the toolkit with support for .NET Core with WPF, added a new bookmarks control. We made improvements to the open source apps, notably significant enhancements to the data collection open source apps. There's a new demo in the demos repo from the .NET team, the symbol editor demo. We added new samples. We released an entire new ArcGIS developer site. And we made many performance improvements and bug fixes. So there's too many things to list here. I'd encourage you to take a look at the blog posts that are linked on the slide.
So one of the things we changed during update 9 was we actually restructured our NuGet package a little bit. So the way that you reference things are going to work a little better for everyone also going forward. So before update 9, what you would typically see would be we had a set of individual packages, one for WPF, one for UWP, one for iOS, and one for Android. And for instance, WPF would automatically take in the WPF dependency, .NET Framework, .NET Core that it would sit on top. And inside that package, you would have stuff like the native libraries of Runtime Core and also our .NET Framework and .NET Core managed assemblies sitting on top, and similar for all the other platforms as well. On top of that, we had .NET Standard Reference Assembly, and that really just contained APIs that were common to all the APIs. And when you did reference this, if you were then using that in a WPF application, or .NET Framework application, I should say, then this would be pulled in. If you're building a UWP, this would be automatically pulled in. So this one is really much more than sort of like a proxy for access to the other APIs. And so if you're targeting .NET Core, you're automatically saying, hey, you want to build WPF apps. And that might not actually be the case going forward and could be a little bit misleading. On top of that, we had Xamarin Forms standard assembly sitting on top as well. For update 9 and 4, what we've done is we kind of turned that whole thing upside down a little bit. So now we have a .NET Standard 2.0 assembly with just all the common functionality that across all the APIs that are mostly actually anything that's really not UI specific. And below that, we have a set of runtime packages that just contains the native library. And so you would notice now it says, doesn't say if .NET Framework or something. It just says, if you're running this on a Win32 application, pull in this library. If you're running UWP, pull in this native library. And really, this just deploys a DLL for the native library that this one can then call into. But it doesn't dictate, for instance, that if you're building a Win32 app, you need to have WPF as well as a dependency. On top of that is actually those packages you knew from before. But now, if you want to build WPF, you say, I want to reference the WPF package. So it's actually a much more clear way to say it. And that pulls in the WPF dependency. None of this will pull in WPF dependency, even though you didn't actually say it, and so on and so forth. So this will actually go all the way through and end up pulling this package right here, pull this package, and pull in WPF dependency. So that's how you would get all these references when you reference this one. And one thing to note is, if you reference this, you no longer get the WPF assemblies by default. You have to explicitly reference this one instead. So if when you're upgrading to update 9, you might have to change that around if you were only referencing this one. And then again, on top of this, Xamarin Forms sits here. This basically just extends the existing UI controls and abstraction into the Xamarin Forms namespace. And this kind of opens it up for something new in the future. So in the future, we'll be able to add more things like, well, we already released this as a preview of WinUI support. We'll cover that some more later. But by reference to this, you might be building either a Win32 app or a UWP app, but you're not using anything from WPF. So there's no way this will force you to reference all the WPF assemblies as well, just because you want to build a UWP app. So this is something to really keep in mind, that the runtime common and NuGet package no longer just adds the UI controls. You have to do that very explicitly to add that reference. However, if you do a reference .NET Core 3.1 .NET Framework, it will pull in the WPF dependency. We mostly did that for backwards compatibility. So just something to consider. But if you move to .NET 5, that will be gone. And going forward, that's kind of how we're going. You can always pull the WPF dependency in if you're not already doing that explicitly. By in your project file, simply add that use WPF true, and automatically pull in all those references you need to access all the WPF assemblies. Or of course, if you reference our WPF package, that would also happen as well. So with update 10, we added full support for .NET 5 as well. Before that, we had it for a while now. We had support for .NET Core 3.1. And while you could use it with .NET 5, there were some incompatibilities that wouldn't work in .NET 5. So we have now full support for it. So I want to talk a little bit about why you might want to move from .NET Framework or from .NET Core 3.1 to 5. So there's quite a lot of reasons. If you want to get all the latest, greatest language features in C#, then this is where you go. The greatest performance improvements, greatest new APIs as well. .NET 5 and beyond is really where you want to be. .NET Framework is still supported, but it is at the point where it only receives maintenance updates, and you won't really see much new functionality. You won't be able to use some of the latest language features. Another thing you get with .NET Core 3.1 and especially .NET 5, where they're more or less complete, is Nullability Annotations. And we'll cover that a little bit more later, but it gives you a really good way to provide much more null-safe code in the future. Moving from .NET Framework, you also see a lot of performance improvements that improved a lot in .NET Core 3.1 and even more in .NET 5. I have a little link to a blog post that goes through a lot of the stuff that you get for free in just by moving to .NET 5. If you're coming from .NET Framework, you've probably never really been editing your project files directly, because they're just kind of a big mess, and get a much cleaner project structure with the newer projects. I'll show that in a minute as well. Another great benefit is I can use .NET 5 or .NET 3.1 and not worry about whether the user have 3.1 or 5 installed, because they actually installed side by side. This is a problem with .NET Framework, because if you wanted to use something from .NET Framework 4.8, you had to have users install it. And when they install that, all their apps will run on the Framework 4.8 runtime. And that might be a problem for them to do, because it could jeopardize other apps they run, which suddenly will run on the latest runtime. But here you actually get to pick. And then if you target .NET 5, you actually get direct access to all the newer Windows Runtime APIs. And I'll be showing some of that a little bit later. But it really means that you get the latest, greatest APIs, for instance, Bluetooth and geolocator APIs, without having to do anything extra work for it. It sort of comes just for free. And the recommendation is for Microsoft, you want to move to .NET Core. If you start a new project, you should start on that. .NET Framework apps really just meant at this point for maintenance, and we really recommend you to move forward, or even upgrade your apps if you're able to do that. And moving forward with .NET 6 that's coming out in November this year, we'll also be running for iOS and Android. So we'll kind of not having both a mono runtime and a .NET Core runtime. It'll be the same runtime as well. So it really sort of unifies the whole thing, so we have more consistent behavior across all. So we really recommend you start moving. In fact, we've even removed the .NET Framework project templates from our installer because we're trying to follow the recommendation of new APIs, or sorry, new applications should be using .NET Core or .NET 5. Here's just an example. We ran some performance tests, and here's just a little benchmark where we just create some spatial references. And we compared the execution time on .NET Framework 4.6.1, .NET Core 3.1, and 5 that we all compiled for. And we saw an improvement in cases where up to, in this case, like 40% improvement without doing anything. Just by moving frameworks, we got better performance for free. All I have to do is retarget. So that's one example of where you might get some benefits. This is one specific case. It's not like you're going to get 40% every single place, but there's many places where you get it. And there's also a lot of new APIs in .NET 5 that allows you to do something a lot more efficient. In fact, if we look at a different case here, there are some new string marshalling features in .NET Core that we took advantage of. So we wrote some specific code for .NET Core, and that's why you see here almost double execution time on just getting a string out of an attribute. And we're still talking very, very small, like nanoseconds here, but in overall it can start adding up to being a lot of performance improvements. So it's not a very good reason. It's just pure performance. You get better performance by moving to the latest frameworks. So how would you do that? Well, typically you would take your framework and you will just retarget. And here's this really short project file. So this is what I was talking about. .NET Framework project files are usually not this simple, but for .NET Core, they are really, really short, and they only have like the things you really want to set on a lot of defaults for the rest. So typically you target .NET 5, Windows 10, 8.3.6.2. That's sort of like the framework we have to target for using our stuff. That does not mean you have to have that version to run on. You'll see right below, I also say that I support Windows 8.1 and up. But if you don't specify that, it defaults the minimum version to what you say in target framework. So I recommend setting the support OS platform to whatever version it is that you're requiring. So typically you just create it on the core app, and currently our project template we created 3.1, but you can just change the target framework to 5. And so let's just do that real quick. So I have an app here, and again it says 3.1. This is typically what you get right out of the box when you create a new project template. But if I were to change this now to target framework 5 and support a platform 8.1, that's really all I have to do. Now my app is building against 5. You might see an error like this that has a little problem restored. Sometimes that happens when you upgrade your target framework. Typically all you have to do is just get rid of the object folder. That would sort of trigger a restore, and then you shouldn't have to deal with that again. That usually only happens the first time, and their rebuild succeeded. One thing I noticed is, let's say I want to target 8.0 or 7 for that matter. We'll see I'll start getting some warnings here. And it says that all these APIs are not supported on 8.0. And that's because we don't support 8.1. So you actually get automatic warnings for APIs you might be using in your application that is not supported. And you could guard against this. So you could still say, if I want to use an API that's available on a specific version of Windows 10, but not before, you can write a little API check before that, whether that API can be used. And then you can kind of write fallback mechanisms. So you can still run an older APIs without jeopardizing that. So an example here, I'm going to go in the main window. And so here I'm actually using the Windows Runtime API straight up. So here I use the geolocator that they have. So this is not something you can just do easily before, but with when you're targeting the Windows 5 on Windows SDK, you get sort of these APIs just for free, and you can call all the latest, greatest APIs. And we can use that, for instance, to access Bluetooth devices, to get high-action GPS devices, which we'll cover a little bit later. So I would really recommend you considering moving. Our plan is long-term that we will be moving to .NET 6 when .NET 6 ships, and that'll be then the minimum required. .NET 6 will be a long-term servicing. Currently 3.1 is, so that's why we support that. But as the new long-term service versions of .NET comes out, we will generally move to be up to be the minimum requirement. So it will be, as the current plan is, it'll be .NET 6, .NET 8, .NET 10. The interim between versions we will also support as well. So that's sort of where we are headed going forward. A new thing we've added is the ability to store your credentials across sessions. So every time you launch your app, you might be asked for credentials, and it can be kind of annoying that you have to sign in every single time if you know that just your device and you're the only user of it. And we want to make it super easy for you to kind of create that experience where every time you launch the app, you're still signed in. So this is an opt-in only thing. You have to opt in for it. We don't want you to store credentials without your knowledge, so you opt in for it, but it's super simple to do. And we provide a default storage implementation with using the secure storage that iOS, Android, and UWP provide. We don't have one out of the box for .NET Core and .NET Framework, but you can provide your own as well. So the way you typically would do this is you would create a new persistent object. In this case, you can use the default one that will create one on the platforms that support it, and it will just automatically hook up. And this is really the only line of code you would have to add to do that. Once you sign out, you want to call remove all credentials. That one will just clear all credentials the way you normally would sign out. And that would automatically sync with the persistence store and also clear the credentials from there. Just be note that setting the persistence instance to null would actually not clear the storage. It was just stop using that store. But you can also use that for having multiple persistence objects in memory, and you can switch profiles by switching the persistence object between different profiles. And it would automatically replace all the credentials that are being used for your session. As I mentioned, you can also create your own persistence object. So we have a get credential method that will just return all of them. And of course, you will get called every time you add, remove, or clear the credentials. And it's then your job to design how you want to save them in the way that is the way you want to do it in your organization for securely storing your credentials. So you have the ability to do it your own way as well. But let's take a look at what that might look like in an application. So I have a pretty simple app here that starts with just moment of sign in. It goes to the sign-in when the application launches, and it just creates a portal. And here I require login, and that will automatically prompt me for signing to my organization. And then I navigate to my main page. The main page is really just a view model here that is bound to the view. And in the view model, you'll notice that the first thing I do is I load the portal items from that portal, get all the users' content, and then the ones I want to actually display, and then show in a list and populate it. So let's real quickly run that. So you see the very first thing that happens is it asks me for my password and my username. So I do that. It's now logging in, and here I go, and I can start opening all my private items that are in my in my portal as well. So that's pretty cool. And I'm not going to sign out. I'm just going to close the app. And then I'm going to launch the app again. And you'll notice once again, I'm asked to sign in. And I do this all over again just to get back to my portal. And that can be kind of annoying. So let's actually add that one line of code I showed. So I'm just going to, when my application launches, I'm just going to hook up the persistence to the default one. And I'm going to run my app. And again, of course, I'm asked to sign in because I haven't stored any credentials yet. And that works just the way it did before. There's no other code changes. We're not going to sign out. I'm just going to close the app, and I'm going to launch it again. And you should notice this time, I hopefully should not be asked. It goes just straight to signing in. Of course, if I do want to sign out, I can click the sign out button. That'll, again, just call the remove all credentials, set the portal to null, and then just navigate back to my sign in page. So if I click that, I'll just go back to workflow again, and all my credentials are cleared. That's a quick little demo of how you could do these kind of credentials and create this experience really easy just with a single line of code. So another thing we added in the Update 10 release is the support for parsing NMEA data from GPS devices. And this allows you to have like external GPS devices, for instance, really high accuracy ones connected to your laptop or your phone and so on. And the way we did that is we provided a new set of location data source APIs. And you see them right here, where it's basically a new NMEA location data source class that just extends the existing location data source that was already there, that you can then hook up to the location display on the map, or just use it by itself. Typically what we do is you would just take the NMEA location that's just created, but you can also have the option for specifying a specific spatial reference that the device reports in, if it's not the standard WS84. You can also provide some kind of transformation where with output you want it to output in, as well as a datum transformation if you want a really accurate transform. And then the location you get is not just a standard location, you actually get an NMEA location that extends that location with additional information like the dilution of precision, height about geoid, the satellites, the differential GPS information, and so on and so forth. And so the way you would use it is you construct the location data source, and then you need to hook it up to some kind of input that has the NMEA data coming in on. In this case here, I'm just using the serial port in the .NET Framework and .NET Core APIs to open a port to serial port 3 at a baud rate of 9600, which in this case is maybe the baud rate that my device is using. I'll open the port, and then I'll just hook up the stream of the port to the NMEA data stream, and then start the data stream. So this is a very generic way you can do it with any sort of stream and hook it up to the NMEA data source. A different way you could do it is you can actually create a subclass of the NMEA location data source. In this case, I created just a little simple class that takes a port and a baud rate and then constructs that port. But it doesn't actually open the port. It waits until the start method is hit to actually open it. And this prevents you from not actually using your port and blocking it while the data source is not actually in use. And the same thing on stop, it will actually stop using it. So it kind of handles that life cycle of the port as well. This is kind of common you're doing something like this. So we provided a little helper method where you can just have a little stream creator that takes a delegate, and in this case port open, and return the base stream, or stop, the same thing, it just closes the port. So it's essentially the same thing as the custom class, but just a little simpler shorthand way to do it without having to necessarily create a subclass as well. We also provided some helper method that takes this like one step even further, and we just basically pass in the port or the Bluetooth device. And these APIs would be very API device specific. So you might not have a serial port API on the iOS version, and the Bluetooth device types are different on iOS and Android and Windows as well. So let's take a little example demo that here's from the GitHub demos repo, and I'll just walk through what that could actually look like. I'm just going to switch to my little Visual Studio app here. This is just a normal WPF window. And the very first thing I do is I'm going to get a list of all the ports that are available. And I have just used the serial port get port names, will give me all the ports that this PC has available and populate to a drop down in this case. I'm just going to launch the app real quick. And so here we see all the list. And I know that my device is connected to serial port 3. And its baud rate is 150,200, so I'm going to open that port. And let's step in here. So the first thing I do is, in this case, I'm using the approach of a custom location data source class, but I could also just have done the stream creator that I have right below here. And so this jumps in here and it just creates the ports just as I mentioned. I'm going to set a little breakpoint on start because notice I do not start the app right away. And so once I hit the location place enable that I just hooked up to that data source I created, it's going to start the data source. And so it doesn't start until I actually start my data source. And here I get the location. You can see I have a horizontal accuracy of about 1 meter. It's a GPS fix with 44 satellites and pretty good dot values. And I have a little sky view here that I can bring in that shows you all the current satellites that I'm tracking right now. And it has a really good spread over the sky, which also correlates with the really good dilution and precision values I'm currently getting. So if I'm on Windows Runtime APIs, I can use those for UWP or .NET 5. I can actually use some different serial port APIs as well. That gives me a little information about the serial port. Might even give me some information which device is connected to it, which can be provide you a much better device picker for the user than just the COM1, COM2, COM3. Similar with Bluetooth, you can also just get access to Bluetooth devices right here and create them. Again, here in both cases, I'm just selecting the first device I found, but of course you probably want a device picker for the user to pick from. If you're running a UWP app, note that you might also use enable this in the manifest because it's running in a sandbox and you have to to inform the user that you might be connecting to these devices. So here I provide the serial port as the device type. Similar for Bluetooth, it's also a serial port because it's called serial over Bluetooth. And so that's the sort of Bluetooth devices that this app would then be allowed to connect to. This is not something you need to do when you're not running as a .NET Framework or .NET Core application, because it's not a sandbox the same way. If you go back to my app, you'll actually see I had that code sort of hidden in here, where when I get all my ports, I actually use these APIs instead to get it. So if we were to compile this with .NET 5, I would be using those devices. Another nice benefit of the runtime APIs is I can actually monitor for changes to my ports and then update the list. So if I'm connecting or disconnecting my device, then I will actually be able to detect that and then update the drop-down list and act accordingly. If I'm on Android, I also have to enable it in a manifest. And here, not only do I have to enable Bluetooth, I also have to enable the location, because you can use Bluetooth to get a person's location through Bluetooth beacon. So it's a requirement to also turn that on as well. And the way to do that in find the right Bluetooth of devices, you actually have to use this GUID that defines the serial over Bluetooth protocol in Bluetooth. And it's kind of an obscure string, but it's actually well-known documented value. And so basically you go through all the bonded devices and find the ones that has the right unique ID, and that'll give you a list of anything that supports serial or Bluetooth. In this case, again, I'm just picking the first one, but you probably want to display a list for the user to pick from which device they want to connect to. On iOS, it's a little more interesting. Here you can only connect to devices that are MFI certified. And that kind of puts a little bit of limit of what devices you can use. For instance, Bad Elf is an example of a GPS you can use, and you have to enable that specifically, and each device has their own what's called an accessory protocol. And you put that in your info plist where you enable this devices you're allowed to talk to. And so what you do is you'll go to the shared accessory managers, connected accessories, run through them, find the protocol strings, or the ones that support that protocol string. And then you have this from accessory helper method that'll generate the device. One interesting thing to note is that with the Bad Elf GPS, you actually have to send a little packet to enable NMEA. So in this case, here's an example of one of those packets, which is all documented in their own documentation. And I can really just take the data source and NMEA data stream and just write that byte array straight to it, which also enables some other interesting functionality where you can send data to the GPIO while it's running. And that gets me on to working with really high accuracy devices. You actually have to feed it corrections from an external nearby data source. And Ntrip is a typical protocol to do that over the internet. And so what you can do is you can connect to one of these called Ntrip services, connect to a socket there, and just take the bytes as they're coming in and just forward them straight to the location data source output stream. And that gives you these really high accuracy GPS devices. And I'm just going to go back to my app here. And I have a little Ntrip client that can do that, and it'll be in this demo app as well. So I'm just going to click Get Streams, and I have two Ntrip streams available on the server. I'm going to pick the second one and say Connect. And so here I jump into actually where my little client will open the stream, and we'll go in and we'll read from the buffer. And as data comes in, I will literally just write it straight out to the NMEA data stream. So you can see this is actually the serial port. So it just writes it straight out and basically forwards all the data that are incoming. And so we can see here the bytes are then being forwarded. And it's not a whole lot of data, so you don't need a super high accuracy GPS. But what you will notice is now that my fix went from TPS to float RTK, which is pretty decent. It's not the good fixed RTK because my antenna is not in a really great position, but you can already see now that the location is getting significantly improved because they're getting those corrections forwarded to the device. And on a good day, I can get down to always about 1 centimeter accuracy here. And this demo you will be able to find on GitHub on this link, ArcGIS Runtime Demos.net, and just look for the external NMEA GPS sample.
In this next section, we'll take a look at using web stars with ArcGIS Runtime. Styles are a relatively new feature in ArcGIS Runtime. They are containers for distributing symbols. Styles can contain vector symbols, which mean they provide high-quality rendering on any device at any resolution. Dictionary stars are a more advanced form of style, where symbols are dynamically composed at runtime from the individual parts within the file based on an arcade script. You create or publish styles with ArcGIS Pro. Mobile styles you share as files. Web styles are accessed as portal items. The ArcGIS Runtime API provides a common pattern for accessing and filtering styles, whether local or online. Support for the mobile style was added to ArcGIS Runtime at version 100.6 in 2019. Mobile StyleX files can be created and populated with symbols using ArcGIS Pro. They're then deployed on devices along with your apps, or downloaded or sideloaded. Web styles are new in the latest version of ArcGIS Runtime. They are published from ArcGIS Pro as portal items, and ArcGIS Online provides web styles containing the default 2D and 3D styles you're familiar with in ArcGIS Pro. And you can publish your own styles containing your own custom symbols. Working with web and mobile styles is showcased in the symbol editor demo in the .NET Team Demos repo, as we'll see in the next demonstration from my colleague Preeti.
Hello everyone, my name is Preeti Maske and I'm a product engineer on ArcGIS Runtime SDK for .NET. At Dev Summit last year, we showed you how you can access ArcGIS Pro 2D and 3D styles in an ArcGIS Runtime application. You do this by creating a new empty mobile style file in Pro and either copy-paste symbols across from out-of-the-box styles or create and add your own custom symbols to mobile styles. That mobile style file can then be added and deployed with your ArcGIS Runtime application. You must be wondering why use style at all? Why not just stick with simple symbols or picture marker symbols? Reason for using styles is that you can get beautiful vector symbols created in Pro that scale well and look good at any resolution. You can highly enhance your ArcGIS Runtime application by making use of these beautiful vector symbols. Let's see that again to recap or refresh our memories. So here I am in Pro and this is my custom mobile StyleX file that I created, and I essentially copied all the symbols from the default 2D style into my mobile style file. So these symbols are exactly the same. If I go back to my project, I added the same StyleX file as my resource and I've used the OpenAsync method and I'm pointing to the resource that I added to my project. Let's see this in action first. So once my app is deployed, I will choose to edit one of the symbols. Let's pick the symbol and I will pick up a symbol from a symbol style, and you can see the symbols are instantly available because these are being fetched from a local style file. If I change the category, the filter will search the symbols based on the category that I select, and I can pick up any symbol and accept it and apply. That beautiful symbol coming from a local style file is easily applied on my renderer. So this is all cool, but I'm more excited to show you that in the latest release of ArcGIS Runtime, you can now access Esri registered 2D and 3D web styles or your own custom web styles that are published on ArcGIS.com, your organization, or your own custom portal. Well, what are web styles? Web styles are styles that are published from ArcGIS Pro to ArcGIS Online or your own custom portal. Let's go step by step. Let's first look what is available as default from Esri. So just like in ArcGIS Pro, we have a set of 2D and 3D symbols. Esri provides out of the box 2D and 3D web styles published on ArcGIS.com. These styles very closely match default 2D and 3D styles we see in ArcGIS Pro, and these styles are accessible to client apps via their registered unique name. So each style essentially has a unique name by which it is identified on the hosted item. Let's look at some of the code to understand it better. So here I have code that is opening a symbol style file and I'm passing the style name Esri 2D point symbol style. This is the Esri registered style name for 2D points hosted on ArcGIS.com. I'm passing portal as null because I want to fetch my symbol from ArcGIS.com. If I want to fetch my resource from a custom portal, I'll create an instance of that portal and pass it in the portal parameter here. Let's see this in action first. So I'm running that app again, and I will pick to this symbol again and symbol style. So as you can see, it is taking a couple seconds to draw the symbols, and the reason being it is reaching out to ArcGIS.com, fetching Esri 2D points style, web style, and populating my symbol picker with all the symbols based on the category currently selected. So if I change the category, it will make another request and fetch all the resources, which is essentially the symbols in this case. And once they are fetched, these are available in the picker, and I can pick any symbol and apply and hit apply. So very interesting, right? So here what I've essentially done is I'm just pointing to the Esri registered style name and passing it to my constructor, to my method OpenAsync, which will actually go to ArcGIS.com and fetch my 2D styles that are available online. Super cool, right? Now you must be wondering, I want to do this with my custom style files. How can I publish my own custom symbols? So the answer is yes, of course you can do it. And let's see how you will do it. So I'm back in Pro, and in the interest of time, I have already created a 2D mobile style file, which I will add here. And as you can see, it has a bunch of vector marker symbols. Now I will choose to publish this as a web style. I'll right click on this mobile style file and I'll say share as web style. I will add few details. And if you notice here, it is asking me to pick a style type, 2D or 3D. Just so you know, web styles cannot be a mixed bag of 2D and 3D symbols. Here I know that I have only 2D symbols in my mobile style file, so I'm picking 2D as the type, and I'm sharing with everyone so I can use it in my application easily. So at this point, it is publishing this symbol style and hosting it on ArcGIS.com in my organization. As soon as it is done, we'll go back to the app and add some code. Let's look at what is published here. So here is the item that got published as part of this publishing process. Let's go back and use this in our app. So here, I will use OpenAsync again, and this time I'm going to pass in the URI of the item that I just created. And I'm calling it as custom style. Let's run the app again. So this URI is actually the web style that I published online. Let's go and change symbol for this guy here, pick a symbol style, and as you can see now, it is showing up that custom web style, and all the symbols from that custom web style are available in the picker and can be filtered based on the category. These symbols match what we saw in the mobile style file. So I can pick any symbol here and hit accept and apply. And that beautiful vector marker symbol from a web style published on my custom organization is now accessible in ArcGIS Runtime application and can be used just like I would use any local style file. So just to recap what we saw in demo today. So we saw how you can access web styles from an ArcGIS Runtime application. Local style files are styles that are available on disk, and all symbols are available in the local style file. However, web styles are hosted online and all its resources are remote and are fetched dynamically when symbols are requested. You can access a web style from ArcGIS Runtime application just like a local style file. In the end, I would like to mention that the sample that I'm using is available on GitHub here. So this is the demo repo for .NET, And here is the sample app that I'm currently using in my demo. All the links will be shared at the end of the demo. This is all from my site today. Thanks for watching, and I hope you like the demo. Have a good day.
Nullable reference types are a relatively new C# language feature, released in late 2019 alongside .NET Core 3. This feature has the potential to eliminate null reference exceptions. These are some of the most common and annoying errors in .NET. Sounds promising? We thought so. So, over the past year, we've worked to take advantage of this .NET feature in a Runtime SDK for .NET. There are two parts to nullable reference types. First, Nullability Annotations allow developers to declare when null is allowed or expected in a parameter, property, variable, or return value. Previously, you had to rely on detailed documentation to describe such specifics, but now it can also be expressed concisely right in the code. Next, nullability warnings are reported by the C# compiler to catch potential null-related bugs for you. These annotations give compiler the necessary knowledge to detect null-related problems, such as passing a null parameter where it's not expected, using a potentially null value without checking, and other subtler problems too. Let me give you some practical examples. I built this simple runtime application that displays deforestation data from around the world, and I can click on deforestation hotspots to view some details about them and to zoom into them. This seems to work pretty well, and my project built with 0 warnings, but if I click outside of a hotspot, the application just crashes with a null reference exception. So let's see what nullability can do for us to help diagnose and fix this kind of problem. First, I'll go to my project file, and I will enable nullability. Now, this happens to be a WPF .NET 5 project. When I return to my source code, I see that several new warnings have showed up. Here, the first result variable may be null, and we're passing it to a runtime method that does not accept nulls. Now, this can happen when there are 0 geo elements, so first or default gives me a null. I'll fix this with a simple null check. But just below, I see another warning that I didn't expect. Here it tells me that when GeoView is tapped, the location can be null. Turns out this can only happen when I have a scene view and I click somewhere out in space. I probably wouldn't have found this in testing, but I bet my users would. So I will add a null check here as well, and that takes care of the last of my potential null conditions. When I run application again, I can see that clicking anywhere, in space or on Earth, works just fine, thanks to nullability. To take full advantage of nullability warnings, both your application's code and your dependencies should have consistent nullability annotations. In .NET 3.1, Microsoft began the process of shipping nullable annotations for all core .NET libraries. In .NET 5, this work is practically complete. I'm happy to report that we too have been busy, and Runtime 110 shipped with full nullability annotations on all our APIs. I recommend enabling nullable reference types for all new projects targeting modern versions of .NET. If you are upgrading an existing codebase, adopting nullability annotations in your code is also a worthwhile investment. It already helped us identify and fix a few edge cases in runtime itself this year. It will likely catch a few latent bugs for you too, and give you more confidence when refactoring or adding features later. Thank you.
It's now time to wrap up the session with a look at the road ahead. On the road ahead for ArcGIS Runtime SDK for .NET, we have some truly exciting new developments that we're reasonably confident about on the near-term roadmap. And we're also really excited about the major developments for .NET coming later this year and what these will mean for ArcGIS Runtime SDK for .NET. In the near term, we're looking at supporting the new application platform for Windows, WinUI 3. This takes the modern user interface and user experience of UWP and makes it available to Win32 environments and UWP environments. Earlier this year, with our 100.10 release, we published a preview of ArcGIS Runtime support for WinUI 3. We also updated the samples with a new WinUI 3 based sample viewer, which you can find in our public GitHub samples repo. We'll talk more about our plans for WinUI 3 support in the session ArcGIS Runtime Road Ahead. And we're also looking ahead to later this year and .NET 6 and thinking about what this means for the application platforms supported by ArcGIS Runtime SDK for .NET. .NET 6 will replace the .NET runtimes used today by UWP, Android, and iOS. Xamarin Forms will evolve into the .NET Multi-Platform App UI, MAUI. So what does this mean if you're starting new work today? Well, certainly if you're starting with WPF today, then we encourage you to at least start on .NET Core 3.1 or later, rather than the existing .NET framework. As we showed earlier in this session, we're already seeing significant performance difference with WPF when running on .NET Core 3.1 or .NET 5 when compared to the .NET framework. Thank you for watching this session. We hope you enjoy the rest of the conference. Hi everyone, we hope you enjoyed the session this morning. We're available now to take some questions. We'll answer the questions that you've been posting in the Q&A channel. Anything that we aren't able to answer in the time available this morning, I encourage you to head over to the Ask Our Experts area and look for the Runtime SDKs section, and there's a number of our colleagues there who can help answer the questions. Or there's also the Esri community where you can reach out to us and we'll help answer your questions there. So let's start with some of the questions. Well, one of the questions is, what are the runtime license issues to consider? So there's probably several considerations that you should make for licensing your runtime apps. The first is the approach to licensing that you take. You can either license with an ArcGIS named user identity, or you can license with a license string. So if it's a named user identity, then you're authenticating with the ArcGIS system. That license you can persist for up to 30 days offline. But if your application needs to be licensed and is not connected beyond those 30 days, then you should consider licensing with a license string. You also need to think about the license level. So there's a number of different license levels, and they're covered in the documentation from light, which is free, through basic, standard, advanced, and then there are also extension licenses available as well. And there's an increasing set of functionality available at each license level. So I've posted an answer in that question with some more information there.
There's also a question about Xamarin versus the native ArcGIS Runtime SDKs for mobile apps. Like, what are the pros? What are the cons? So assume this is a comparison with using .NET SDK versus using the native iOS and Android SDKs. With respect to cons, they're not really different. So most of the code in the runtime is actually written in native code, and it is the exact same stuff we deploy for Android and iOS native SDKs as Xamarin does. We do expose it with slightly different code. So like we use .NET to expose these APIs, or those native APIs, and iOS and Android uses their like Java or Objective-C. So that code might be slightly different, but in general, everything below it is the same. And even those differences in iOS, Android, and .NET is we generally take their code and port it to C# and recompile it. So there should be very, very similar. So there really shouldn't be too many cons, especially like performance and stuff like that, because in the end, it really ends up being the same binary code that's running. A con might actually be, like, if you're talking the native SDKs, well, you have to build an Android app and an iOS app completely separate. So you'll have to basically build the same thing 2 times. With Xamarin, it gives you the ability, especially with forms, to share all your UI and your business logic. So if you're targeting both platforms, looking at some of our cross-platform SDKs, then it could be Qt as well. It could also be an option. And again, even Qt will use the same native libraries to target these or to run the runtime APIs as well. So it shouldn't be too many different there. Another question running out in Xamarin about Xamarin evolving into .NET MAUI. Are you anticipating any impact, positive or negative, on the runtime SDK and capabilities? So we didn't go too much into .NET MAUI, but for those who are not aware, Xamarin Forms is sort of getting replaced by .NET MAUI, so it's more like a refresh of Xamarin Forms. That'll be shipping it's planned for shipping in November, and we hope to be able to support that like very soon after. And there's sort of like a Xamarin Forms like for a year, where Xamarin Forms continues to be fully supported before they sort of expect everyone to move to MAUI, and we want to be there and support you as best as we can. I don't anticipate anything like negative around that for us. Of course, it's more work. And that's of course a negative because it's more stuff to test and so on. But again, because the underlying native APIs are really the same thing, it shouldn't really be much different. It's sort of just, we have to rewrite some of our forms code, but all the native code and even a lot of the .NET code that hits the native SDKs directly will be the same. So it's just a little bit slightly different layer on top than we currently have with Xamarin Forms. It's definitely to clean up a lot. So you'll be able to just use a single project to target all the platforms instead of one for Android, iOS, and Windows. So I hope that covers that. But it's still a little bit early. We haven't started the work yet ourselves.
So there's another question here. What are the ways we can handle data latency issues over mobile connection? I think this question might be somewhat tricky to answer without a bit of a dialogue. So I'd encourage you to go ahead over to the Ask Our Experts area and look for the Runtime SDK section and post that question there. But there are a number of strategies that are available for working with data and offline data in terms of whether you request offline maps and offline geodatabases in an ad hoc on-demand way, or whether you follow the pre-planned workflow where you pre-generate maps that are available. The way we design and build the API tries to ensure that we, I suppose, minimize the use of the connection, and also that we're resilient in the downloads and things that we do in terms of perhaps chunking and resuming downloads. But yeah, I'd encourage you to head over to the Ask Our Experts area to follow up on that one.
Another question we're getting about, and it's kind of along to the NMEA demo I did, is a truck driver has to be able to follow a route on the app as he's driving. Application has to detect when spring switches turn on and off, and Bluetooth connection. Should I use a Bluetooth connection or a serial connection? It has to be reliable. So there's concerns about the Bluetooth connection not being up. Of course, with any wireless connection, there can be interference, it can get dropped. My experience with Bluetooth, it's most of the instability really relies on which device you're using, both the GPS receiver and the mobile device or PC that's connected to it. Sometimes those drivers can be unstable. You don't have that, at least you don't have the wireless part of it with the serial connection, obviously. There is at least that concern will be reduced with serial connection. I would say I've seen that with .NET Framework, especially the serial port APIs are a little unstable themselves. That has been improved with .NET 5 if you're using the WinRT APIs instead. And so there's another thing there to consider. And especially with Bluetooth, you should actually consider using .NET 5 again, because the Bluetooth APIs in Windows 10 are exposed if you're using Windows. But it's sort of a trial error, I would say. You should write your code error prone. You should be able to, you can write code that checks that the connection is still running and restart the connection if it should drop. So that's another thing to consider, to have like more error resilient, like if you start getting data through. We've done some sample code that is not built in for detecting error in the stream, but it's totally possible. And I'll be more than helpful to help give some pointers how to do some of that, or in the Ask the Experts forum, if that'll help. Second question here is, I have started a basic Xamarin Forms app that is just showing a basic map. It works when starting with blank, but when I start with a shell app, UWP breaks. Is this a known issue? The shell implementation for Xamarin Forms in UWP is not, my understanding, is not fully complete, and it's not. There's issues with it for sure. It was, most of the implementation was community contributed and wasn't complete. And as far as I know, the Xamarin team hasn't actually fully completed it. So definitely shell has issues in UWP. That's sort of a known issue, but that's probably more an issue to speak with Microsoft on. So I would encourage to go to the Xamarin Forms repo and post an issue there, and they can follow up or help you resolve that.
There's another question here. What are some of the differences between App Studio and Xamarin? So App Studio is a product that's created by Esri that enables you to build and configure mobile applications that are multi or cross-platform mobile applications. It's actually built on top of the ArcGIS Runtime SDK for Qt rather than the ArcGIS Runtime SDK for .NET. So as part of the App Studio workflow, you can actually download the application that's created, and you're able to extend it and customize it beyond the application that's created. But at that point, you're working with the ArcGIS Runtime SDK for Qt. Xamarin, by contrast, is a set of APIs that are built on top of ArcGIS Runtime SDK for .NET, and you'd be building an application from scratch, or you'd be looking at some of our samples and demos, open source apps, and potentially pulling pieces from those and building your own application. So yeah, I definitely, depending on your development experience and skills and knowledge, App Studio can be a great place to start to build an application, and it also supports publishing to the various app stores. So it provides you with a full workflow for building cross-platform mobile applications.
Another question I have is, should we be moving our WPF applications to target WinUI 3? That's a good question. I think it really depends on your scenario. I would probably lean towards no. First of all, WinUI 3 is still, they just released like full support for it, and we don't fully support it yet, and might wait until the 1.0 release of WinUI 3. So there's still some time, some ways out. I think there's a lot of good stuff in there, and I think long term that's what we'll be using. We won't be. I wouldn't be using with WPF longer term. I think taking your existing app and porting might not be worth it unless you expect to gain some specific things from WinUI 3 that you don't get from WPF today. We definitely see some better rendering performance and so things like that in WinUI 3. So there are some benefits, but if you have a big application running on WPF, that it might be a little premature at this point, I would say. But if you're starting a new project towards the end of the year, it's something I would definitely consider.
Here's a great question about licensing. I'm currently using 10.2 WPF SDK to provide some backend GIS functionality via web services. Is the Runtime SDK what I would use to update this functionality? Are there any licensing issues using Runtime strictly on the backend? Unfortunately, ArcGIS Runtime is not cannot be licensed or isn't permitted for use as a backend service-based capability. It's for building single user applications only. So unfortunately, use of ArcGIS Runtime in web services, kind of back-end scenario, isn't supported, and currently would break the terms of the license.
I think we're pretty much running out of time. There's one more question in here. We're probably gonna have to reply in the thread. But feel free to come over in the Ask the Experts forum and ask more questions and reach out to us. And thanks for joining us.